In Lesson 14C, we're going to talk about a different formula, which is the formula for blood alcohol content. I like this material because they always try to find things that are somewhat interesting or somewhat pertinent, and this is something that we've all either dealt with or seen or heard of, is how to calculate blood alcohol content, or the fact that they use blood alcohol content for determining whether or not you have the police have a case for a DWI or something like that. So when they're talking about blood alcohol content, when you hear someone say that had a blood alcohol content of 0.3, what that means is 0.3 means 0.3%. Now remember, 3% would be equal to 3 out of 100. So when you're talking about 0.3%, you're shifting the decimal over 1, and 0.3% would actually be 3 out of 1,000. So when someone says they have a blood alcohol content of 0.3, that means that 3 grams out of every 1,000 grams of blood is actually alcohol instead of blood. So this would be very high. A blood alcohol content of 0.05% actually impairs reasoning and the ability to concentrate, and a blood alcohol content of 0.3, which is what we were talking about here, can lead to blackout, shortness of breath, and loss of bladder control. So 0.3 is a really high blood alcohol content. 0.05 is when your reasoning starts to be impaired. And in most states, the legal limit for driving is actually above 0.05. It's actually at 0.08. So you're actually impaired before that, but they've decided that the level for legality is 0.08. So this blood alcohol content is usually determined by a breathalyzer, or it could be done by a urinalysis where they test your urine, or it could be done by a blood test. But a Swedish physician named E.M.P. Widmark developed an equation for estimating an individual's blood alcohol content, and it's a formula that's widely used by forensic scientists. Now, just for decision-making processes, realize that if it's used by forensic scientists, that means it's used on people who have died. So there's a reason that they want to determine the blood alcohol content of people who have died, and that's because a lot of accidents are caused by drinking. So when you're looking at blood alcohol content in this formula, the B just stands for blood alcohol content. The N stands for the number of standard drinks. And of course, in the formula, N has to be at least 1 for this to even really make sense. And a standard drink is either a 12-ounce beer, a 5-ounce glass of wine, or a 1.5-ounce shot of liquor. So any of those would be constituted as 1, of an N of 1. W is the weight of the person in pounds. G is what's known as the gender constant, 0.68 for men and 0.55 for women. You can argue this fact, but the facts are that, I guess you can't argue the fact because this is a fact, that men metabolize alcohol faster than women. There's always kind of the running joke of, women can't hold the alcohol as much as men. Have heard that maybe before, but the fact of the matter is they can't. Women don't metabolize alcohol as fast as men do, and that's why we have to put in a different number based on gender. And then T is the number of hours since the first drink. So it's the total number of hours that you've been drinking. So if you started at 5 and you had 3 drinks and it's midnight, the 3 drinks doesn't matter for this number. What would matter would be the 7 hours since you've had your first drink. So you would put in T of 7, and then N in that case would be 3. When you're out drinking, you have to be careful because sometimes a bartender won't give you 1 standard drink, especially if you're talking about a glass of wine or a shot of liquor. A beer is a little bit more steady because they usually have a fixed size glass, or you may get a bottle or a can of beer. But when you're talking about wine or a shot, that's up to the bartender to serve. So you may end up getting more than 5 ounces, think you've only had quote unquote 1 glass of wine when you've had what might be equivalent to 2 glasses of wine or 1.5 glasses of wine. Same thing with the shot. The bartender might be trying to be quote unquote nice and give you kind of a large shot in your drink. And so you have what you think is 1 drink and it ends up being equivalent to more than 1 drink. So if you're trying to determine, if you've had enough or too much to drink, you have to take those things into account. So it says, consider the case of a male student who has 5 beers and weighs 180 pounds. Simplify this equation as much as possible for this case. What variables are still unknown? So we're going to start to fill in this equation. This person's blood alcohol content. We've got this, which is steady, negative 0.015. That's a constant. That doesn't change. We don't know how long they've been drinking, so T is still T. Plus 2.84 is also a constant. N, we don't know. Oh, no, we do know. It says he's had 5 beers, so N is 5. So we're going to put in right here, instead of an N, we're going to put in a 5. And this dot, of course, means times. On the bottom, weight is 180. And G is that gender constant. And since it's a guy, we're going to put in 0.68. And they want us to simplify this. So if we look at the numbers that we have here, we can't really simplify this because it's got the T in here. So we're going to leave that alone. But over here, we can simplify this entire thing. I'm going to do it in 2 steps, although you could do it kind of all at once. If you do want to put it in your calculator all at once, you'd have to put a parentheses around this and a parentheses around this so that the calculator knew that you wanted to multiply and then divide by the multiplication of this, so it would do the order of operations correctly. You'd have to do parentheses 2.84 times 5 parentheses divided by parentheses 180 times 0.68 parentheses. I think it's a little safer, and I would recommend that you just do the top and the bottom separately and then divide. So 2.84 times 5 gets you 14.2. And 180 times 0.68 gets you 122.4. And so now our simplified formula for this student is negative 0.015 T plus 14.2 divided by 122.4, which comes out to be approximately, and I'm going to go out 3 decimal places since this one went out 3. I'll go out 3 with this one, and it comes out to be 0.11601, so I'll just do 0.116 since it's got a 0 after it. So this is the simplified version for this student drinking 5 beers. Now it says, using your simplified equation, find the estimated blood alcohol content for the student for 1, 3, and 5 hours after his first drink. So now we've got this all constant. The student's weight isn't going to change. We're going to keep the constant at 5 beers, and the student's going to remain the same male student, so the gender constant doesn't change. So the only thing that's changing in here, the only formula that or variable that we have left is this T, and we're going to change that T and see how that affects his blood alcohol content. So 0.015, it says 1, 3, and 5 drinks. So we'll put in a 1 for T, not 1, I'm sorry, 1, 3, or 5 hours. So we're going to put in a 1 for T for the time. And if he's had 5 drinks in 1 hour, I would assume his blood alcohol content is going to be fairly high. So negative, don't forget the negative, 0.015 times 1 plus 0.116. And that's going to put his blood alcohol content at 0.101. So we're not to the point of passing out and such, but we're definitely over the impaired limit and also over the legal limit. The legal limit, remember, is 0.08. So next we have 3 hours. So after 3 hours, would he legally be okay to drive? And we've got negative 0.015 times 3 plus 0.116, and that gets us 0.071. So technically, at this point, if the formula is working correctly and all, should be at the legal level to drive. But remember, he's still impaired because above 0.05 is impaired. So even though he's legally okay to drink, he would be somewhat impaired. And then if we put in 5 hours, this is still not going to put him at having no alcohol in his system, but it's going to put him probably below the impaired level. Yes, so at this point he's at 0.041, which puts him below what they say is an impairment level, but definitely still has alcohol in his system after 5 hours. So now it says record the sequence of steps you took to get from time to blood alcohol content and be specific. For example, did you multiply, add, subtract, what values in what order? So I'm not going to write this down, but what we did is we took the negative 0.015, we took it times the time, and then we added 0.116. Each time for this student, because of the constants that we already had, that's what we had to do. We just had to take negative 0.015 times the time, and then add 0.116. And if you do that on a scientific calculator, it will do all the steps in order. In fact, the way this is written, the multiplication would happen first anyway, so whether or not you had a scientific calculator or not, it would still do it okay, because it would do it from left to right. But technically, multiplication should always be done before addition, and a scientific calculator would take care of that with no worries. So we're continuing with 14D, but we have the same scenario to start with that we had in 14C. It said use the same formula that we had before. Find that simplified formula for the 180-pound male who drank 5 beers. And this is what we had. We had the 2.84 that was the constant, the 5 drinks, his weight, the gender constant. And when we simplified that up, we got negative 0.015T plus 0.116. And it says, what sequence of steps did you take to determine his blood alcohol content after 3 hours? And after 3 hours, we put in a 3 here. And it came out to be, I'm just going to kind of sneak this in right here. His blood alcohol content after 3 hours was negative 0.015 times 3 plus 0.116, which came out to be, that was the one that was like 0.7 something. And that one was 0.071. So not 0.7 something, but 0.07. So 0.071. So now what we're going to do is we're going to look at this a little bit differently. It says, how long would it take for this student's blood alcohol content to be 0.08? So this is kind of like when we were talking about the problems before and we were trying to figure out what would their weight need to be to have a certain body mass index, or what would their height need to be to have a certain body mass index. We're going to need to solve this equation a little bit. So we're going to start with the simplified version because we've already got that. We don't need to reinvent the wheel. But it says we want the blood alcohol content to be 0.08. So in this formula, we're going to put 0.08 for the B, and then that's going to equal negative 0.015, and we're going to leave T as an unknown because it wants to know how long will it take. So T is what's in question here. And we're still going to have plus 0.116 because that was part of that simplified formula. So we have this simplified formula now where instead of inserting a T and finding out what B is, we're going to put in a B that we want. We want that blood alcohol content to be 0.08, and we're going to try to figure out what T is. So remember, we're going to work the order of operations backwards. And so there was, parentheses, exponents, multiply, divide, add, subtract, and we want to work backwards. So we want to undo any addition and subtraction first. So over here, the first thing that we're going to do is we're going to subtract 0.116 from both sides. If it helps you when you're doing these equations, you might put a dotted line where the equal sign is so that you know whatever you do on one side of the dotted line, you have to do to the other side. So I'm going to subtract 0.116, and the reason I'm subtracting is because it was an addition, and I'm trying to undo it. I'm trying to get rid of it. So these would cancel. So 0.08 minus 0.116 is going to give me negative 0.036. And that's okay that that's negative. That's because we're going to have a negative on this side also, and they'll end up canceling each other out. So it's negative 0.036 equals negative 0.015 t. Now, one mistake that I see students do, and it's understandable, is at this point they see this negative and they want to add. But think about the operation that's going on here. This is not a subtraction. In this case, you're multiplying by t, negative 0.015 times t. So you're not undoing a subtraction, you're undoing a multiplication. So to undo a multiplication, you have to divide, and you have to divide by the same thing you multiplied by. So we're dividing by negative 0.015 because that will cancel with the negative 0.015 on top. So we're going to divide by negative 0.015, and then we'll get what t is, because now on this side the only thing that's left, these are canceled, remember, the only thing that's left is this t. So this is going to equal t now, and negative 0.036 divided by negative 0.015 gives you 2.4. So in order for this student to be at the legal limit, if he wants to drink 5 beers, he's going to need to give himself at least 2.4 hours. This is time. So 2.4 hours before he would be at the legal limit. Remember, that's not under the impaired limit, that's just to the legal limit. Would still be impaired all the way down to 0.05. This is only 0.08. So now we're going to look at a different student here, and we're going to plug in the information that we have for her. So here it says a female student weighing 110 pounds plans on going home in 2 hours. And we're supposed to first determine their simplified formula. So let's put in what we know for her. I'm going to slide this over and do it off to the side. So for her simplified formula, we would have that her blood alcohol content would equal negative 0.015. We know the t in this case, so this is a little bit different scenario. It's not the number of drinks that we know, it's the time. So we know her time is 2 hours. We also know this constant here is going to remain 2.84. We don't know the number of drinks. They haven't given us that. We know her weight is 110 pounds, and we know her gender constant, since she's a girl, is 0.55. So if we simplify this time we're not going to be able to get a single number over here because this n is here. But we will be able to get a single number here. So we're going to still have a variable of b. Negative 0.015 times 2 would be negative 0.03 plus 2.84n over 110 times 0.55 is going to be 60.5. So I can't simplify this whole thing, but I can simplify the bottom here. Now, like before, I could take 2.84 and divide it by 60.5 and just get a single number, but I think that's bothersome a little bit. It's hard to see where it came from. So I like to leave it like this. If you did do that, you could change it to a single number of 0.047 times n. But I think that small number is bothersome, and I think it makes it hard to see where things came from. So I like to just leave it like this. So now it says for this student, if she has 1 glass of wine now, what will her blood alcohol content be when she leaves to go home? So if she's going to stay, remember, she's staying for 2 hours. So her scenario is a little bit different. She knows I need to leave at this certain time, and we're trying to figure out, you know, what would different number of drinks do to that based on stopping or leaving after 2 hours. So for B, we're going to put in 1 drink. So B equals negative 0.03 plus 2.84 times 1 over 60.5. I'm going to do the number on the right first, so 2.84 times 1, of course, would be 2.84, and then I'm going to divide by 60.5, and that will get me negative 0.03 plus 0.047. And if I add those together, negative 0.03 plus 0.047, I get 0.017. So she's well under even the impaired limit, let alone the legal limit. So 0.05 would be impaired. She would be well under that if she had 1 drink and waited 2 hours. The next question, though, says, what if she has 3 glasses of wine? So we're going to do the same process, but instead of a 1 here, we're going to put in a 3. So B equals negative 0.03 plus 2.84 times 3 over 60.5, because all these other things, her weight and her gender and the number of hours, all stay the same, so I don't need to redo that. I can just use the simplified formula and put in the 3. So that would give negative 0.03 plus 2.84 times 3 equals, I'm going to hit equals and then divide by 60.5, and I get 0.141. As I do these, it's not a bad idea to type these things into your calculator and make sure you're getting the same thing so that you know you're entering it correctly, so that when you go to do your homework, you're confident that you're entering it correctly. And this comes out to be negative 0.03 plus 0.141 comes out to be 0.111. So she definitely wouldn't want to have 3 glasses of wine and leave after 2 hours, because she's well above the legal limit here. Legal limit is 0.08 and she's at 0.11. So she's 0.03 above the legal limit. So the last question it asks is, okay, well, if she's above the legal limit, if she's below the legal limit at 1 and she's above at 3, how many can she have? Let's put in the legal limit of 0.08. That's what it asks. It says, calculate and estimate how many drinks she can have and keep her blood alcohol content at 0.08. Still leaving after 2 hours, not changing any of that. So 0.08 equals, we're using this simplified formula right here, equals negative 0.03 plus 2.84 n over 60.5. So what steps do we need to take to solve for this n, to get this n alone? Well, I'm going to put the dotted line down the middle because I think that really helps some students to kind of keep track of things. And what do I need to do first? Well, remember, we're going to work that order of operations back, so we're going to take care of any addition and subtraction first. So this is adding a negative number, and adding a negative number is like subtracting. So I'm going to add 0.03. And the reason this isn't the same as what we did before is that this isn't multiplied by anything. This is just added to this number. So to get rid of adding a negative 0.03, we're going to add a positive 0.03. and that'll undo. So these will cancel, and I get 0.11, and that will equal this 2.84 n over 60.5. So now we have two numbers here that I need to get rid of to have the n alone. The first is, well, there's two things. If you were working this, the order of operations, you would take 2.84 times n and then you divide. So to undo that, I need to undo the division first, working backwards. And so I'm going to multiply by 60.5 to get rid of it. So to get rid of this 60.5, I'm going to multiply by 60.5. And then that will cancel. And on this side, I also need to multiply by 60.5. And 60.5 times 0.11 gets me 6.655. And that equals this 2.84 n that I have on this side. And now to get rid of 2.84 n, that's a multiplication, so I'm going to divide. And do that on both sides. That way the division will cancel the multiplication, and all I have left on this side is n. And 6.655 divided by 2.84 is 2.34. Now 2.33 repeating is a third, so basically we're saying she could have 2 1/3 drinks. If she wanted to be on the safe side, she probably doesn't want to order a third drink and not drink all of it, so she probably should just order 2 drinks, and she would be under the legal limit as long as the drinks were that standard size. So 2 drinks in 2 hours would be good for this person. That's kind of a standard that you hear sometimes, is a 1 drink per hour is fairly safe. Again, I don't want to make any promises or say anything, but this is for somebody who's 110 pounds, so she should be able to, and it's a girl. So most people, unless they're under 110 pounds, whether they're a guy or a girl, since guys metabolize even faster than girls, should be able to handle about 1 drink an hour. Again, though, don't tell the police officer that your math teacher said that you should be okay, because I don't want to be responsible for that. So hopefully this helps you understand this formula, and you'll definitely see this formula when we have the exam, and it'll be on the review. So we'll pick up with lesson 15 next.